Modular programming. So today we are going to study about modular programming. So what is it modular programming? Modular programming is a process of subdividing a computer program into separate subprograms. It's a process of dividing a large program into subprogram. That's modular program. A module can be considered as a software component. It can often be used in a variety of applications and functions with other components of the system. You can see an example. So this is a bike having different modules. Light manager is there, safety manager will be there, brake manager will be there, gear manager will be there, stock manager. So all these things are different modules of a bike. So next question is, when we do modular program. Till now we have been writing C program, but we are not doing modular programming. So what's the need of doing a modular program? When the size of the program is large, there is a chance of getting errors. That is, some program might have thousands or billions of lines, and to manage such program, it becomes quite difficult, as there might be too many syntax errors or logical errors present in the programs. So what we need is we need to split up. So what are the features of modular programming? Each module contains something necessary to execute only one aspect of the desired functionality. In the case of bike, brake module will be there. That's a unique module only for brake applications. So that's the main thing. Modular programming emphasizes on breaking of large program into smaller problems to increase the maintainability, readability of the code, and to make the program handy to make any changes in future or to correct the errors. That's the main advantage. We can make, if we are writing a program as modular, we can individually correct the modules. That's the main advantage. Points to be considered while doing modular programming. So we have to consider certain things while doing modular programming. First thing is, limitation of each and every module should be decided. Where to divide? Okay, what are the components? What are the modules? We have to identify the limitations of each and every modules. In which way a program is to be partitioned into different modules that we have to consider. Communication among different modules of the code of for proper execution of the entire program. Because if you want to execute, if bike should work, all these modules should work. So we have to consider that also, how these modules is been communicating. Okay, advantage. A lot of advantages are there. First one, ease of use. This approach allows simplicity, as rather than focusing on the entire thousands and millions of lines of codes in one go, we can access it in the form of modules. This allows ease in debugging the code and prone to less errors. So it's easy of use. Second one is easy reusable. So same brake module can be used in another bike. It allows the user to reuse the functionalities with a different interface without typing the whole program again. Next thing, ease of maintenance. It helps in less collision at time of working on module, helping a team to work with proper collaboration while working on large applications. So these are the main advantages of using modular programming. How to implement modular programming in C program? Okay, C program language divides the problem into smaller modules called functions or procedures, each of which handle a particular responsibility. So we will be writing functions for doing modular programming. The program which solves the entire problem is a collection of such functions. So we will have a lot of functions. A function is a set of statements that take input, do some specific computation, and produce the output. Take the case of a module break. So break module will be represented in C program as a function that will take input and process that and gives a particular output. The idea is to put some commonly or repeatedly done tasks together and make a function so that instead of writing the same code again and again for different input, we can call the function. So that's the main advantage. We can reuse the components. So first step of going for modular programming, we have to declare. Function definition is the first part. Function definition tells the compiler about the number of parameters function takes, data type of the parameter, and return type of the function. So these are the three things we have to you write while declaring a function. So first thing is we have to specify the return type of the function. Return type of the function should be specified. Then there should be a name to the function. Then the parameters. Function declaration tells the compiler about the number of parameters function take, the type of the parameters, and return of the function. Okay, we'll check an example. Void main. This is very familiar function that we have been using nowadays. So in this case, return type is void. Function name is main, and the arguments, we are not specifying any arguments here. So this function, main function, is not inputting any values. After completing the function, it is not returning any value. That's the meaning of void main. Consider another example. Int max int int. What does it mean? Name of the function is max. It will take two inputs, integer inputs, and after completing the function, it will return an integer value. So that's the thing. It's a return type is void here. Function name is main with no arguments. Here return type is int. Function name is max. Arguments are two. It's like two arguments. Here we are not specifying the variables that we'll see in the next slide. It's always recommended to declare a function before it is used. So it's always recommended to use function declaration before it is being used. Okay. Putting parameter name in the function declaration is optional. So we have two options. Either we can write like this: in max int a int b, or in max int int. Parameter name in the function declaration is optional, so you can write both. So after writing the function, you have to give a semicolon. This is the format of function declaration. This is the first step of modular programming. We have to declare the function that we are going to use. So next step, function definition. So what's the difference between a declaration and definition? Declaration indicate what function is. So it shows that, okay, max is a function, it will do a max operation. But we are not doing that. We are only declaring it. And in the definition part, we are actually doing that. The function definition indicate what function does. So for that, it should have the body. That means what it should do. The body of the function is specified in the definition. So here, for example, max function is there. We have written and body here. What function should do. That's the definition. The declaration is, it is to indicate the compiler that, okay, this is a function. This is a job of that function. But actual thing will be defined in the definition part. Okay. So max function, check whether a is greater than b. If true, return the value of a, else return the value of b. So this is a max function. So that is a definition. So it will be clear, I think. Declaration means we are just declaring what the function is. In the definition part, we are specifying what function does. Next thing, calling a function. How we are going to call the function? While creating a function, you give a definition of what function has to do. Okay, so we have done that. To use a function, you will have to call that function to perform the defined task. So we want to call that function. When a program calls a function, the program control is transferred to the called function. A called function performs a defined task, and when a return statement is executed, or when its function ending closing brace is reached, it returns the program control back to the main program. Okay. To call a function, you simply need to pass the required parameters along with the function name, and if the function return a value, then you can store the return value. So, you see an example. So this is a function declaration part. I have declared a function int max int semicolon is there. So the main function is a function we are currently in. So this main function is going to call the max function. So in order to call the function, we want to specify the function name. So function name is max, and we have to check whether arguments are there. So max function is having two arguments. So we will pass two values. P and Q value is being passed. Then we will check whether that function have any return type. Okay, this function have a return type int. So I am specifying that also. That's the thing. That's r equal to max pq. So what happens is that when we write like this, when it executed this line executed, it will this function will call the max function, and the control will be passed from the main function to the max function, and max function will execute the statement. It will return in this statement, this point, return a if the value of a is greater than b, or it will return here. So after completing this function execution, it will return back to the main function. That's the thing we have written. Okay, so I think it's clear. So to use a function, we will have to call that function to perform the defined task. We are calling the function max pq. So that's the thing. When a called function perform a defined task, when it return statement is executed, or when function ending closing brace is reached. Here the program is ending in the return statement, or the program will be executed completely, and at the end of the closing bracket it will be returned back. This will be return program control back to the main program. To call a function, you simply need to pass the required parameters along with the function name. If the function return a value, then you can store that the value is been returning, this function is returning the value that is been stored in another value. So this is the way we are going to call a function. Okay, we will see one little more. Here the main function is calling the max function. The parameter passed to the function are called the actual parameters. So another thing, so the parameters passed to the function are called the actual. Here the actual parameters are p and q. P and q used by the called function is called the actual parameters. P and q. The parameter received by the function are called the formal parameters. Here the formal parameters are a and b. So two terms, actual parameter and formal parameter. P and q is called the actual parameters of the function, and a and b is the formal parameters of the function. So, next thing, we can pass parameter passing techniques. So there are two type of techniques are there. One is passed by value, and next one is passed by reference. In the first step, in this parameter passing method, the value of the actual parameter are copied to function's formal parameter, and two type of parameters are stored in different memory location. So any change made inside the function are not reflected in the actual parameter of the caller. Next step is passed by reference. So both actual and the formal parameter refer to same location. So any change made inside the function are actually reflected in the actual parameter of call. We will see an example. First we will take the pass by value case. So what it's saying that this pass by value, we have been copying the actual parameter to the formal parameter, and both the information will be stored in different memory locations. So here is a function, swap function is there. It is, we are calling the function swap pq, and these two the function definition is here. So pq is the actual parameters and ab is the formal parameters. So we'll see example. Initially I am assuming, okay, memory address of p is 1000, memory address of q is 2000, memory address of a is 3000, and memory address of b is 4000. So initial memory status is like this. P and q have values 5 and 6. So memory status after function call. So we have been calling the function swap pq. So function is been called, and this swap function start to execute. So at that point, what's the memory status? A will be have another copy 5 and B will have the copy 6. So we are performing the swap operation. A value is being changed to 6 and B value is being changed to 5. What we can see is that actual parameter P and Q is not being changed, not being altered. Only the formal parameter is being changed. That is pass by value method. So any change made inside the function are not reflected in the actual parameters. That is pass by value method. Next one, pass by reference. So we will be using the same memory location for both formal and actual parameters. We will see that. So I think, okay, it's end. So we'll have a T. Let's have a break.